real quick, we're a user experience product. We try to solve a similar problem as products like Control Up and Uber Agents and SysTrack and that kind of stuff. We do it, I believe, in a better way. We take the approach, at least from a better way, which is a top-down approach. We start from the users, what the actual user's doing, and what the user thinks is going on, and then kind of work our way down to some machine data, as opposed to starting with machine data. When I say machine data, that means stuff like Windows Performance Monitor, Windows Event Log, the stuff that the machine's generating rather the user says or does anything. Right? That's always being generated, it's always there. So we focus on just what the user says. We did go over this dashboard a little bit, but I wanted to spend a little bit more time on this. So you can't read this, thanks to this beautiful, this is a smart word, I didn't know if anything was going to happen. Anyway, so this says user experience rating. This is a percentage, and what this percentage is, it's really, so we collect every application the user touches and uses, and we track how long they use that application. Another metric we track is how long that user ends up waiting for that application to respond. So if you open up Outlook and you do file open and it takes 5 seconds for it to pop up, that's a wait for the application. Does that make sense? So we track that information. And so what the percentage is this is the percentage of waiting time versus active, what we call active productivity time. Like how much time am I spending waiting on applications to respond and to do stuff. So obviously high number here is bad. Matter of fact, I would say anything over 5% is probably a negative impact for the user. Anything above 10 is probably unbearable to some degree. If you spend 10% of your time waiting for applications, you would not be a happy camper. So this is just an overall rating for that. We also have what we call application delays. Application delays are the things I was talking about, where if the application doesn't respond, and when I say doesn't respond or it takes time to respond, I'm not talking about the infamous not responding, right? That's a Microsoft thing. It's Microsoft saying, we send a request to this application and it's no longer telling us anything, so we assume that it's dead. So we're not tracking that in this particular case. What we're tracking is the application, we send an application, request to the application, it's acknowledged that it's got the request, but it hasn't told us anything else. So we call that a wait time or an application delay. And then what we do is we calculate that over time. So these numbers by default is for your environment. So these are averages for your environment. So your average user experience rating, this is on the laptop. It's data from 2 weeks ago. So it's not always, this is probably not, hopefully not predictive current. Hopefully this is in your environment. It doesn't look like this, but the average delays, this is in hours, or not the average days, so this is the collective amount of delays during that period. So 7 hours of delays. So it's basically 1 man day you've lost in waiting for applications to do stuff in this last 7 days, right? This is log-on delays. So just like application delays, what a log-on delay is the amount of time it takes from the time that you type in your username and password and press go to the time the operating system is usable by the user, right? So that's what we call, that's the log-on duration. And so you spent 3 hours and 23 minutes in the last 7 days waiting for log-ons. These are web loadings. So we don't just do Windows applications. We also do browsers. We support Chrome, Firefox, Edge, and IE. And we will tell you all the things that are going on with those browsers, the sites that they're going to, how long they spend on the sites, and we also collect 2 bits of information, which is the page request. So when I send a page request out, and then we'll also, and how long that first page request, or the first, I'm going to send out a request. When I get my first response, we're going to tag that and make that a time. And then the second metric is how long did it take to download a page. So once I make a page request and I download the page completely and I render it in my browser, that's a page load, right? So those two different things. Those collectively is the total load time for a browser or page. So we're collecting all that information. So this is the amount of time currently that you're waiting for that. This is data indexed by us over this time period. This is a Splunk. This is an important metric from a Splunk perspective because Splunk you pay for by megabytes or gigabytes ingested on a day. So, I mean, this is really, so this is a 7-day period. In 7 days, we've only ingested 256 megs. The free license for Splunk will let you do 500 megs a day. So, you could be at, I don't want to do math, but, 3.5 gigs and still be okay in a 7-day period.
What do you like any sizing with what you're...
So our approximate data usage per user daily is about 98% of a meg.
Okay.
I don't know the exact. It's just short of meg.
Okay, yeah.
But I use meg as a differential. So from my perspective, just to be safe, because you always have the possibility of like a rogue user doing something spinning, causing more data than you would typically have. So my general rule of thumb is for 450 users and below, you can use free Splunk. Which for a lot of you guys might be most of your or all of your environments. And the reason why that's important is because that is a significant cost savings. A 1 gig license for Splunk is about $5,000. So a perpetual license for Splunk for 1 gig, I think is about $5,000. So if you don't have to pay for that, it's great. Splunk gets a lot cheaper as you get more gigabytes. Like a 20 gig license isn't a lot. It's like, let's say like $20,000 or something like that. It goes down as you get more and more space.
Now, do you have to use Splunk, or do you guys have your own?
No. So right now, when you have a product like this, or even if you're in the big data market at all, like there's two components, right? The component that we sell and really the value is the data. So the agent is agnostic. It doesn't care. So that you can tell the agent to send it to any IP address, and you can tell it to send, I think, one of like 7 different formats. It will send the data in whatever. It'll send JSON, CSV, key value pairs, XML. There's like 7 different formats we'll send it to. So you can send it to Elastic, you can send it to Hadoop, you can send it to SQL, you can send it anywhere you want to. For our perspective, so that's great for the product, and that's what the agent is. The agent's agnostic as far as the back end. But you guys are going to want to know what the data is and what the value of the data is, and you're going to want to be able to show it to your customers and stuff like that, right? So we can't realistically build free applications for Elastic and Hadoop and all that kind of stuff.
No, basically you're saying you can whatever.
Any backend you want.
But you're building your own dashboards from there on. If that's Splunk.
So effectively, this is our product, right? So effectively, it's a Splunk product because your go-to-market or your ability to take it to a customer currently is to use Splunk. If they already have Elastic and they have developers for Elastic and they understand how to search data in Elastic or Hadoop or any of these things, then you can say, hey, look, you don't have to buy Splunk, you can integrate this in. But you would use Splunk to help them visualize what that data is and how it's valuable, right? Because if they don't understand what the data is and how it's valuable, they're never going to buy a product, right?
Correct.
No one's going to buy something they don't understand just because it works for Elastic. Anyway, so that's why we decided to invest a lot of energy and effort into building Splunk dashboards and stuff like that, and then offer the Splunk app for free, so that you can illustrate value and have a go-to-market without having to worry about designing a whole product on top of Elastic, Hadoop, and all the different platforms. So this right here, any other questions? This right here is a data summary. So we'll tell you all the number of users, the host, the index data, the amount of index data. So you'll see right here, the reason why it's even as big as it is because I did a data import on one day. I imported 258 gigs, megs of logs in one day, so you could actually have something to look at. Anyway, but this will tell you how much megs you're indexing a day. This will be your average user experience rating for that day, and then your activity hour, and I think there's nothing else on that one, yeah. So that's the only thing on that panel. This is a very similar view, but instead of being a table view, it's actually just the delays and the user experience rating, and it's a time chart with, this is your warning, this one right here is your warning threshold. So if you exceed this threshold, we'll actually trigger alerts and warnings, which you'll see down here, or you'll see in a second, it's down here. And then we'll actually give you, these are your average app delay, logon delays, and if you had web delays, which like the two little purple ones here, those are web delays. Right? Does that make any sense?
So this is collecting for everything, whether it's locally installed or remote app?
Well, I mean, so if you had it running on, you'd have to have it running on Zen app, yeah, it should collect it as well. Does it make sense? Right, so we're agnostic. We don't care about Citrix, we don't care about VMware, we don't care about Microsoft from a broker perspective at least. Right, we just run on Windows. Windows XP and above and Windows 2003 and above. So as long as it's that platform, you can install our agent, we're going to collect data and send it to Spawn.
What's the agent footprint?
I don't know the exact numbers, but according to Andy Wood, right, so Andy did it wasn't a bake-off, but he did the comparisons. He told me that, I mean, I know what we say, but he said we do 7 megs. It was 7 megs of memory and 0.1% CPU. That's 0.1% CPU. So he said by far it was the lowest impact from an agent. So, yay. Anyway, so to answer your question, there is one caveat, and because of the data that we collect has to be running in user context. It can't be running in an elevated context. So when you're doing a published app like Zen you have to use it to run it as a startup script, I think, a login script, because it bypasses the shell. In a standard install, the shell is what starts our user process, starts the process for the user. Does that make sense? So in Zen app, when you have a published app, obviously that process is skipped because they use their own shell process. So for those, and we have on the website there's directions like this is how you install when it's on Zen app, and you get to do like a logon script. It could be a local, like it doesn't have to be a group policy logon script, but it could be like a local script on the box that says, hey, when users log on, just run this process. Okay. So down here are the, I'm going to go back to this in a second. This is kind of gives you your most used web cloud resources, and this is the most used apps. One thing I like about this is that you can get a pretty good idea of what applications and websites are used the most in your environment. And this is actually used. So one of the best things about the way, in my opinion, one of the best things about the way we collect the data is that you can get really accurate licensing type information and usage information because we track it by the time it's actually being used. Meaning, if I use like say Salesforce and I use Skype and all these, I have all the Office applications and Outlook and I have all those things running, but I don't actually use them, we'll be able to tell you that. Yeah, Outlook was running, it was running for the entire time the user was logged on, but the user only used it for 10 minutes or 5 minutes. They had Skype running the entire time, never used it once. So we can give you actually very good license usage information. And the reason why, and we can actually even do that for SaaS applications as well, stuff like SharePoint. So if you have a sales staff, or if you have a lot of companies will use Salesforce and they'll get licenses for everybody. But if I can go in there and prove, hey, yeah, this guy uses Salesforce, but he uses it like to look at internal postings once every week for 10 minutes, perhaps it's not worth the Salesforce license for that guy, maybe you should cut back. Because you have valid data to prove that he was using it or not using it at whatever percentage of time. And it's the same with applications. So you can see if you have an application, because you may have a user that comes, or a group that says, hey, we have to have this application. It's the most important application we use. Everybody uses it all the time. And then you run on our app and you realize it's that one guy who uses it all the time. No one else uses the app, right? And you're like, well, that's actually not true. You're the only one that uses it. You do use it a lot. So why don't we buy you a license and let everyone else use whatever they want? So those kind of things we can actually give you. So down here are the alerts these are application alerts by users. So these are, one thing, I don't know if you know this about Splunk or if you know anything about Splunk. So the way that these charts are built is they have, they look at the data that's coming in and then they size the chart appropriately, right? Because this could easily be 0 to 300 or 0 to 3 and it would look the same, right? Unless you had a situation where you had one spike that's 300 and all the other ones are like 5 or 6. So we'll have like little peaks and then have one big peak, right? So it scales the data from based on all the information that's coming in, or all the ratios that are coming in. So don't just assume big peaks are bad and small peaks are good. It's just an idea to be able to visually get peaks. And now these are situations where we have a lot of alerts based on the numbers of stuff that's going on here. So it's a comparison type chart. This would be one for login domains. And these two down here, this is web response time alerts and web downloads. So again, I send a request to the website, it responds to me. That's what this timer is. This timer is how long did it take the page to download completely. Does that make sense? So, one of the things we can do is we can drill down. I'm actually going to change this time because the date range for this that actually has data in it was. Oh, by the way, that's how you can change it. You can change the time to a lot of different things. You can have it real time. You can have it you can have presets. So these are all the real-time presets. These are relative time, so I want today, I want yesterday, I want last 15 minutes, last 60 minutes, last 30 days, last 70 days. You can have whatever you want. Or in this particular case, since I know that there was a specific date range, I can actually go here and put the date range in that I want to look at. So it's going to be May to that week. And then you just apply, and then it will change all the searches for that time range. Does this make sense? Very, very powerful. All of our searches, we're pretty Splunk savvy. So all of our searches are accelerated at Splunk, which means that regardless if you have 5 users or thousands and thousands of users, the searches should all still be pretty quick. I don't care what you do, 1,000 return set versus a 5 return set, it's going to be slower to some degree. But with accelerated searches, which is a built-in functionality of Splunk, it's sufficiently faster. Like, you almost won't even tell the difference. So one of the things we hear is the top impacted users. And the cool thing about top impacted users is you can highlight somebody, right? So we have this big dot, and the bigger the dot, it's the bigger the number of user experience rating. So if you have a really big dot, that person's a problem. Smaller dots have a problem, but probably not as big of a problem. Does that make sense? So you'll tell you this is, so during this week, Carrie was active for 709 minutes. She has an average user experience rating of 5.8%. So about 6% of the time, she was waiting for applications to do things. With a total of app delays of 41 minutes.
John,
Yes.
so using AppV, the time for the app to stream to your app server, is that a separate figure or is that part of your application wait?
I mean, I don't know. I won't say authoritatively one way or another. I would assume, assume that it would be considered a wait. And the reason why is because the application is active, the request has been made. So it's not responding, it's an inactive state, it's just waiting for stuff. So I would see it acting very similar as the way that a browser would work in a web page. So when I request a web page that's big, right, it doesn't say I'm waiting, like, it's not saying that I'm delayed in regards to, it's not active, it's saying I'm waiting for stuff to happen. I'd have to check it out. I don't know if that's what would happen. I'm actually not even sure directly how res and absence and all of those, like when they do some of the tricky profile stuff and application stuff, I don't know exactly how it's going to respond to that. So for Java apps, what you'll get is you'll get the, using Java apps as an example, similar example, you'll see the process name being Java jw.exe, but then you'll see the class name or the applet name as the title of the application. Does that make sense? So with something like app.v, what you probably see is the launching application as the name of the application, but the title being the name of the actual name of the application. Does that make sense?
One question.
Yes.
Is it possible to hide the usernames or not even collect them?
Yeah, so it's not, yes.
Because it's not allowed in Germany.
So,
Only in Germany, so that's a lot of
yeah, so we already have the ability to obfuscate. So it will collect users, it will collect the computer names, but they will not be directly relatable back to a specific user. Meaning that it will give you a username, but I can't say that that username is Joe Schmo. Right?
It's a fancy username.
Yeah, so it's like an encrypted, or not encrypted because it's not implies that you can get back to their source. It's obfuscated, you don't know what it is.
So you have the big dot, this user is a problem, but we don't know who he is.
Yeah.
That's the way it works sometimes.
That's a German issue I can't solve. There may be a way that you may be able to do lookup tables and stuff like that. Like if it became something that the German.
But from the official side, you can say no.
Yes. Yeah.
That's
So,
all.
yeah, because we do some really cool things everywhere else in the world that Germany's like.
It's Switzerland and Austria.
Yeah. So yeah, we actually have thought about that. We actually do have some customers in Germany, so that we've had to adjust for.
Yeah.
Anyway, so we have an idea that Carrie's having some issues. If we want to click into that, we can actually click into Carrie's name, and we'll go into this dashboard. This, for some reason, is not. I need to figure out if this is. I think this is a bug. This should actually maintain time, but it's not. It's not maintaining time. So I need to go back in here, meaning that when I do the drill down, you'll see in every other place when you do the drill down, whatever time frame, whatever context you're in, kind of follows the search. Does that make sense? In this particular case, since it did a pop-up instead of a drill down inside of Splunk, it's lost context of the search dates. Right, so in the first dashboard, we were doing May 23rd to 27. Now it's like the last 24 hours. Does that make sense? I just wanted to clarify this. So you shouldn't have to do what I'm doing right now. So typically what would happen is you would click, and then this dashboard will come up, and it will give you any it'll give you any user or session that applies to that thing. If you want more detail, you just click that, and it will actually start filling out all these dashboards. MacBook Air, yay.
So your user experience rating is not very good.
Yeah, it's not very good at all. Unfortunately, I'm running those Macs, so I can't really tell you how much time I'm wasting. But, so actually it wasn't this slow earlier. This is generally like instant. Oh, I screwed up. That would take a really long time. It's trying to give me like a month of every single thing that's happened to that user in very detailed metrics.
8 p.m. you went on 4 p.m.
You're kidding me.
No.
It's not even done in 5 minutes. No. Was that 30 minutes? That's not fair. Not fair. Anyway, so this is what you'll get. So this is for the user during that time period. It's kind of, we still have the summary. We have the user rating, number of alerts that we've had for that user, application delay for that total, and login delays for that user's total. The cool thing is down here you have like, you'll see the peaks. So this is the user experience daily, and then you have the purple line, which you can see a little bit here, and you'll see kind of peak up here. That's user experience rating hourly. Right, so this is an average of daily, because this kind of gives you a baseline of what their daily average is. But then you'll see throughout the day you'll have peaks, and those peaks are generally over an hourly basis. So we wanted to show you an hourly peak as well, so you kind of have both metrics. And then you'll see the actual big bars are application delays, web delays, and logon delays. So if you wanted to get in to details, you can actually just drag on Splunk. You just drag the area of time that you want to zoom in on, just by dragging your mouse, and then we'll give you much more detail on each one of those sections. Down here, so in this particular case, there wasn't any web loading issues, so this tab is blank. If you wanted to get rid of it, you just uncheck the box, it goes away. Or if you want to have the web load on and the log on and you want it all there, you can just check the boxes, they pop back and forth. The data is there, so it's just displayed or not displayed. So in this particular case, we just want to focus on apps, so we just go down there. So what this is during this time period, it's all the application wait times by PID, by process IDs. And it's got a big list over here that you can very clearly read. If you look, you'll see the two biggest offenders are the gold ones, which is basically Chrome, right? If I want details on what Chrome's doing, I just click it, and then down here, I will get a detailed list of everything they did in Chrome during that time period. We'll tell you how long they were active, how long did they wait, and you can actually tell, because this is for Chrome, this is true, and IE it's not always true, it's kind of sometimes true, that the process ID is directly related to the tab, right? So in this particular case, in Chrome, they launch a new Chrome.exe or a new PID for every tab. So you can see this person is doing a lot in one tab. She's going from one site to another site. She's not, in other words, it's not like I have multiple tabs open. She's only got one tab, and she's going to different sites. I only have 5 minutes, that's sad. Huh?
Only 1 minute.
Says only 1 minute.
No, she said 5 minutes. She didn't say when that 5 minutes started.
it was 5 minutes.
I'm just using my 5 minutes now.
That's not how it works.
It's not how it works?
It's just how you read the data.
Yeah. I do want to show you one more thing real quick.
Last button.
And that is, I wanted to show you what this looks like. So while we generally don't, where am I looking for? That's right. We don't provide machine data. We will, in our next release, we'll actually be able to capture, if an alert or some condition is triggered, we'll capture for a period of time machine data, but then we stop once the condition is done. So you'll get some exposure as to when it's happening, what's going on, but we're not going to collect it all the time because it's not useful. but I did want to show you some yesterday. So what I was going to show you, so this is the same thing we were doing with Carrie before, but this is actually my session on my laptop yesterday, my VM. And so it showed you that I had 330 event counts. I had an active time of 124 minutes. My average wait time during the 124 minutes of active time was 3 minutes and 45 seconds. But if I click here, this is going to bring in a drill down like you saw for her, but for me during that time period. My 5 minutes starts now, right? And so we'll see the same thing that you saw with her, where this is my activity time by hour versus my activity time, my average user experience rating by time, by hour, by day, and then all the little spiky things. And then if I zoom into this period, down here, you'll see the same thing that you saw with her with the app wait times, the load times. But now, since I have machine data added, I'll actually see extra panels that tell me CPU, memory, and disk during that time period, right? And then if I wanted to go into something specific, let's say like Outlook, I'll be able to tell you, okay, Outlook CPU during that period of time that I'm tracking, this is what I was doing in Outlook. Does that make sense? I guess I gotta go. I guess I should have done a master class.
Next time.
Yeah. Wrong. Cool. Anyway, thank you guys.